I'm Ian McMahon, lead software developer for research and education products here at Rethink Robotics. Today, I want to give you an overview of the Sawyer robot and how it can be used for research and education. In particular, I want to discuss ROS, the robot operating system, which is the communications protocol we use to send data all around the robot. This data can also be received by your robot workstation. This visualization can show you all sorts of data that you can find very valuable when programming robots. First, I'd like to show you Sawyer in RViz, the robot visualizer. Right here we have Sawyer with force torque rings around each of the joints. These rings are actually showing off the amount of effort every joint is experiencing in real time. So for instance, if somebody pushes on the arm, we will see these torques go up and down. Another thing with RViz is the ability to visualize camera data coming right off the robot. So as you can see right here, we have Sawyer sending camera data directly from the Cognex camera, which is monochrome color, in the arm out to my workstation. This is streamed directly in RViz. And we actually have the ability through RViz to overlay the robot model itself in the camera image. This is really handy for computer vision researchers. So as you can see right here, color was just added to the image because that's actually the robot model being overlaid on the image. Another piece of data that you can visualize through RViz is the transforms that are being calculated by the robot. Another really interesting integration with the ROS environment, Sawyer is fully capable of working with Move It, the motion planning framework. You can choose the motion planner that you desire. Here I'm taking the default. And then you can do this programmatically, but here I'm going to show the visual way of creating a motion plan. Grab the arm with your mouse, move it to a particular configuration that you desire, ask for a plan from Move It, and now we're about to execute the motion plan that we just created through Move It. That was a simple trajectory in Cartesian space, but you're able to do much more complex things like avoiding collisions in your environment if you add a Connect sensor, for instance, or potentially moving through many different collision shapes, as well as avoiding self-collision. In order to start the Move It motion planning software for Sawyer, first need to start a joint trajectory action server and then launch the Move It software stack. Here I'm launching the joint trajectory action server. We see it came up and running. Then in the second terminal window, I launched Move It. An RViz screen pops up, and this shows you the motion planning environment. Clicking on the end effector and moving it in 3D space will give the goal pose for the robot arm. Clicking on Plan tells Move It to start creating a trajectory. And then all you have to do is hit execute, and the robot moves to the desired location. Thank you for watching our overview for Sawyer Research and Education. Happy researching!